Before we get away from this topic of centroid of plane areas, we'll try to look at a little mathematical fact, which I would try to call it centroidal axis area moment lemma. Though this may not be directly useful, let us briefly look at it before we get away from this topic. It will be useful at a later point. Let us consider we have an area, some kind of an area, okay, whatever be the area shown over here, which is set up in some kind of x and y axis. Let us say this is y axis, and let us say this is x axis. Let me mark them. This is y axis, this is x axis. Within this axis, we'll try to locate what is the centroid of this plane figure. Let me kind of try to hatch it so that we know we are talking about area rather than the boundary of the Let us say that this area is bounded between y coordinates y1 and y2 as shown over here. Further, let us say that we have identified the location of the centroid and computed its y coordinate, which is shown in the figure here. Let us say we have located the centroid G, which is located at a height of h, shown over here. We know that to compute this h, we need to consider an elemental area parallel to x-axis, that is perpendicular to y-axis, and perform an integration. Let us try to set it up real quick. In this context, let us use a terminology that this line, which is drawn through centroid and parallel to x-axis, as the centroidal axis. Now, to identify the height of the centroidal axis, that is the value of this h, we need to consider an elemental area perpendicular to y-axis and perform an integration. Let me try to show it real quick. To compute the value of this h, we consider a little elemental area shown here, that is elemental area shown by these two lines over here, which are situated at a distance of y, and then we write a formula for this height h as h is equal to, you have something in the numerator, something in the denominator. In the numerator you have integral from y1 to y2, y multiplied by the elemental area dA, and in the denominator you have integral y1 to y2 of just dA. This would imply, that is, we'll take whatever is the denominator onto the other side of the equal to sign and write h multiplied by integral y1 to y2 of dA is equal to integral y1 to y2 y times dA. Now we do a little bit of notation again here. We'll denote this particular height, will denote the height of this elemental area dA above the centroidal axis as the symbol L. With this notation, we see that the y coordinate given by this quantity, that is the height from here to here, is the sum of two quantities, one from here to here and then from here to here. That is, we write y is equal to h plus L. When y varies from y1 to y2, L varies from y1 minus h to y2 minus h. We'll try to use this fact and try to further simplify and see what we get. That is, we'll try to substitute this value of y in here and try to see what we get. Let me just scroll it up a little bit. Okay, so we say that this implies your h times integral y1 to y2 of dA is equal to integral y1 to y2. Your y is h plus L to dA. Okay, this we would write as h times integral y1 to y2 of dA plus integral y1 to y2 L times dA. Now notice that this term on the left hand side of the equal to sign and this term on the right hand side of the equal to sign are identical. Thus they both cancel out and we are left with the equation integral y1 to y2 L times dA is equal to 0. This last equation is what I term it as centroidal axis area moment lemma. If we look back at the figure again, we can kind of state this equation as sum of moments of all areas above this centroidal axis is equal to sum of moments of all areas below this centroidal area. In the case of symmetric figures, we don't have to really take moments of the areas. So for primitives and figures that have an axis of symmetry, we will say that sum of all the area above the centroidal axis is equal to sum of all the area below the centroidal axis. That is the reason why we said when we began with the definition of centroid, we said that centroid is that point which has the property that any line drawn through it will divide the figure into two halves. And we said that applies only to primitives and objects that have an axis of symmetry. In all other cases and general case such as the one shown over here, we say that sum of moments of all areas above the centroidal axis is equal to the magnitude of sum of moments of all areas below the centroidal axis. Because L is positive above and negative below, we say that the total integral between y1 and y2 L times dA is equal to 0. That is what we term as centroidal axis moment, area moment lemma. This we will use it at some other point, so I would encourage you to remember this term centroidal axis area moment lemma. We'll try to see the subsequent topics later.